Welcome to the Dirt on Growing, where we don't just plant seeds, we plant ideas that challenge the norm. I'm your host, Brandon Rust from FulCrop Sciences, and this is the podcast where living soil meets real science. From worm castings to bottled nutrients, microbial inoculants, and chemical pesticides. We're here to question the trends, break down the data, and empower your grow. It's time to think deeper and grow better.
From organics or synthetics. And today we're going to break it all down so that you guys can understand exactly how plants observe nutrients. What we're going to be talking about today is the real chemistry, physics, and biology at the root surface. I promise you, in the next few minutes, you'll get a comprehensive understanding of the ways.
Sorry about that. Technical difficulties. 1 second.
Actually absorb nutrients. Today we're going to be talking about how plants actually absorb nutrients. And you've probably heard growers talk about how plants are forced fed synthetic nutrients. You've probably also heard them talk about how plants don't know or care if nutrients come from organics or synthetics. Today we're going to break it all down so that you guys can understand exactly how plants observe nutrients. What we're going to be talking about today is the real chemistry, physics, and biology at the root surface. I promise you, in the next few minutes, you'll get a comprehensive understanding of the ways nutrients reach the root and the two ways they cross into the plant. So in this episode, we're going to keep it simple, super practical, and you'll learn how nutrients move through soil or solution via mass flow, diffusion, and root inception, and how they cross into the plant either through passive or active transport, where the plant actually spends energy to take up nutrients, and how carbon and chelation change the entire dynamic. By the end, you'll see why some growers get ridiculous efficiency from modest inputs, and others are just flushing away money down the drain. So let's dive in. One of the biggest mistakes is thinking that everything that you are giving to the plant is being absorbed or the plant has access to it. Most growers think that if you put X amount of milliliters per gallon into your reservoir, that's what the plant has access to or what the plant will get. So when things look off, we often find ourselves thinking that we need to either up the feed, switch the brand of nutrients, or add another booster. But here's the truth. Plants don't care what's in the bottle. They care what makes it into solution, to the root surface, across the root barrier, and into their cells. Every step is a potential choke point. So if you're only thinking about the inputs and not thinking about physics, chemistry, and the biological synergy between the nutrients, carbon, microbes, and the root, you could be wasting money throwing inputs into a black box and hoping for the best. Nutrients move in three main ways: mass flow, diffusion, and root inception. You can think of your root system as being surrounded by a zone of soil or cocoa or water where the nutrients are dissolved from that zone to the root. Mass flow is the easiest one to picture. Every time your plant transpires, every time water evaporates from the leaves, it's pulling water up from the roots like a straw. That water isn't just H2O, it's carrying dissolved nutrients with it. So imagine a river of water moving through the soil towards the roots, and whatever nutrients are dissolved in that river comes along for the ride. This is mass flow. It's driven by transpiration, and nutrients like nitrate, calcium, magnesium, and potassium ride this river. This means that any nutrients that are moving via mass flow requires transpiration to be uptaken into the plant. If your VPD is wrong, if your plants aren't transpiring, your nutrient river slows down. If your media is cold, compact, or waterlogged, roots struggle and flow slows down. If your media hydrology is either bone dry or constantly oversaturated, you're also messing with mass flow. So when someone says my plants look deficient, oftentimes the first reaction is add more. The real problem might be you don't have a river, you have a swamp. Fixing your environmental parameters, your watering parameters, and any issues that could slow down transpiration can improve mass flow and nutrient uptake. The second way that plants absorb nutrients is through diffusion. Think of diffusion as a crowded room. One corner of the room is packed with people, another corner is nearly empty. Over time, people naturally drift from the crowded side to the empty side. Nutrient ions do the same thing. If there is a high concentration of, say, phosphorus a little bit away from the root and a lower concentration at the root surface where the plant is sucking it up, P will slowly drift and diffuse toward the root to even out that difference. This is a huge deal for nutrients like phosphorus and many micronutrients. There are three main factors that can affect diffusion, and they are moisture, too dry and diffusion almost completely stops, temperature, like cold, which slows down everything, and soil structure. If water films can't form and connect, ions can't move easily. You can have plenty of phosphorus in your soil solution, but if diffusion is slow, the plant can't access it and it can become deficient. The third pathway is called root inception. It's pretty simple. As roots and root hairs grow through the media, they literally bump into nutrient ions. The more your root system explores, the more it intercepts and uptakes nutrients. Then if you add mycorrhizal to the mix, it changes everything. Mycorrhizal fungus will attach to roots and send out extremely fine filaments called hyphae into the soil. They explore far more volume than roots alone. They're incredibly important for things like phosphorus and micronutrient acquisition. So your root system isn't just what you see when you pull the roots out of the pot. It's roots plus fungal networks all intercepting nutrients out of the soil. So now that we've gone over the three main ways nutrients move through to the root surface, we'll move on to how they cross into the plant cells. You can picture the root like a city with walls and checkpoints. To get past customs to the inner city, the xylem, ions have to go through cell membranes, and there are two main ways this is done: through passive transport and active transport. Passive transport is like rolling downhill. If it is easier for an ion to be inside of the cell than the outside based off of charge and concentration, it can move through specific channels or carriers without the plant having to use energy. This includes things like ion channels for potassium or water and nutrients moving through aquaporins, which are small water channels. Passive transport only works with the natural gradient, but plants don't want the same nutrient concentrations inside the cell wall as outside. They want to control it. They want to concentrate some nutrients and exclude others. This is where active transport comes in. Active transport requires energy, or ATP. Active transport is like walking up an escalator that is going the wrong way. You have to spend energy to fight the gradient. Plants do this with hydrogen, ATPase, pumps in the root cell membrane. These pumps use ATP, the energy exchange currency for all biology, to pump hydrogen ions out of the cell into the space outside the cell. That creates a proton gradient. More hydrogen outside than inside. It also creates a charge difference. The inside of the cell becomes more negative. This allows for nutrient ions to be pulled into the cell. So oftentimes when your plant is taking up nutrients, it's happening through secondary active transport mechanisms that ultimately use energy in the form of ATP. We want to add in this last layer, and it's where things get a little bit complicated. It's all about carbon dynamics. Plants are pumping carbon into the root zone all of the time. They send out sugars, amino acids, organic acids, and phenolic compounds. And they do this to feed microbes that change the pH, solubilize nutrients, and chelate nutrient ions. You can think of root exudates as the plant's currency. The plant is literally paying microbes to do biochemical work for the plant. Carbon and the amount of organic matter and CEC is like the nutrient bank. Organic matter and clay in the soil are like the bank account that hold on to positively charged nutrient ions like calcium, magnesium, potassium, and ammonium. The storage mechanism is called cation exchange capacity. A good CEC means that when the solution gets a little bit low, the bank releases some of those nutrients back into the solution. Or if you dump a bunch of fertilizer, the bank can hold on to those nutrients until they're needed. And then we have chelation. Chelation is when an organic molecule wraps around a nutrient ion like a claw. When these nutrient ions are not chelated, they can precipitate out of solution, they can get stuck to soil particles, and they can become unavailable. When they're chelated by organic acids, amino acids, humic and fulvic substances, they're more likely to stay in solution, move with water, and stay bioavailable near the root. So carbon-based inputs, organic matter, and healthy microbial communities don't just feed soil life in some vague way. They stabilize nutrients, smooth out the supply, and increase the efficiency of whatever nutrients you're already paying for. So the best way to support proper nutrient delivery, not just understand the science, but putting it in practical application, there are a couple of things that you need to know. To support mass flow, you want to have a dialed in vapor pressure deficit, or VPD, so that plants are actively transpiring. You want to avoid constant cold, soggy media, and you also want to manage your irrigation in a way that gives root hairs the best opportunity to grow and proliferate and absorb nutrients. Remember, no transpiration, no mass flow, no nutrient delivery. To protect diffusion, you want to make sure to keep your media from swinging from bone dry to oversaturated conditions. Water management is key for diffusion and mass flow. You also want to maintain good soil structure and avoid compaction, so that way things like biofilms and water films can form and allow the transportation and diffusion of nutrient ions into the root. This is especially essential for phosphorus uptake because it is mainly observed through diffusion. When it comes to root inception, you want to prioritize oxygen in the root zone, soil and media aeration, and avoid any EC levels that can cause osmotic stress and can damage fine root hairs. You also want to make sure to not let your roots sit in cold, stagnant conditions. And lastly, you want to feed that carbon engine. Build or maintain organic matter where possible. Use carbon-based amendments or humic and fulvic acid sources that integrate with biology and support microbial diverse communities, especially around the rhizosphere. You can think of carbon as something that upgrades the software of mass flow, diffusion, and root inception. And those are the things that are running your nutrient system.
So essentially, it's all about that carbon. When we're talking about how force feeding plants with basically synthetic fertilizers, it's because you're basically putting all of those into solution, and the plant has no choice to uptake those things other than through transpiration or the movement of water. The plant has to take up water, and it's going to take up water as much as it can. So the difference is typically not all nutrients are absorbed that way, and it neglects the whole carbon integration and that basically upgrading that software where it creates better stability amongst nutrients. It decreases precipitation reactions. It feeds the microbiome, which has its own plant interactions, and it tries to bypass a lot of natural processes that are basically hardwired and integrated into plant genetics and biology and physiology of the plant mechanisms, where they work. So I hope you guys enjoyed that little video I put together for y'all. I'll repost it so you guys can go back and watch it. I saw a couple of questions in the chat. I answered most of them while the video was going, but the plant does recognize, right? Because when someone says the plant doesn't recognize where the nutrient ions come from, well, maybe the plant doesn't recognize doesn't mean that there's not hardware and software integrated when it comes to carbon and nutrients and plants and biology. Those things all work synergistically together, and to try to deny biology to just push things through solutes you're strictly dealing with chemistry, and sometimes that chemistry doesn't play well together. And a good example of this is one of the reasons why we have to deliver a lot of these hydroponic nutrients in such a low pH is because at a higher pH ranges, or when those pHs start to fluctuate or go back up, what happens is phosphorus binds with calcium and magnesium to form either calcium phosphate or magnesium phosphorus compounds. And those are basically the salt buildups that you'll see in a nutrient system, or that like at the bottom of a res, or that buildup on media. These are basically precipitants which make it so that chemistry is no longer available. And then a lot of it is also just runoff, right? The reason why you can't let nutrients just, that's drain to waste, right? The reason why they're drained to waste oftentimes when we're talking about hydro is because if you were to just leave those synthetic inputs in a system, it's going to cause those reactions, right? And then it's going to spike the EC. It's going to cause a bunch of osmotic stress. It's going to cause harm on that system. And so the plant isn't, inherently built to feed in this way. And so when we're talking about the logistics and the efficiency and the delivery mechanisms that are inherently built in with mass flow, diffusion, root inception, and carbon, it's the only thing that makes sense from a logistics perspective. So I hope you guys enjoyed that. Make sure you guys go check out the website is under construction. So if you have problems, or if you can't order, you can just email us and we'll get you taken care of while we're getting everything debugged, because we are upgrading some stuff on the website and doing some cool stuff. You guys will see soon. Anyway, so long. I'll see you guys next time.